the question. Now let us discuss the question number 15. In continuation to previous question number 14th after question number 15th. So from the in continuation to JEE Mains question paper March 18th first shift 15th question. Here the question is given. 15th question is 2 moles of cyclopentanone subjected to hydrolysis in the presence of sodium hydroxide. We can get X product. X product we get again followed by hydrolysis upon heating. When heating is done, then we can get Y product. So consider the above reaction. The product X and Y respectively are. Options, 4 options are given here. A, B, C, D options are given. Out of the 4 options, we have to find out which is most relevant. So let us try. So what kind of reaction this is? First of all, this is the question taken from carbonyl compounds, and when the functional group present in the reactant is ketone. That means here carbonyl compound subjected to hydrolysis in the base. So what we call means this is self-condensation, or what we call simple condensation reaction. This is simple condensation reaction, we say. So generally condensation reactions are possible in the carbonyl compounds, aldehydes and ketones. So aldehydes and ketones, so that having alpha hydrogen. So this self condensation and simple condensation. So all condensation reactions possible. Here ketone is given, and here 2 moles of pentanone, subjected to hydrolysis in the presence of aqueous solution of sodium hydroxide. We get X compound further subjected to hydrolysis, followed by the heating. Heat is done here. We can get what product we can get is that Y we get. So what we should get means X and Y we should find out. So what will be the X and what will be the Y? So as you know that aldol condensation associated with the removal of alpha hydrogen. Now take here I am taking one cyclopentanone. Here is the functional group alpha carbon. This is functional group. Just adjacent one is alpha carbon. Here alpha hydrogen is present, and so when this alpha hydrogen, that means this ketone is treated with the nucleophile. The nucleophile attack this alpha hydrogen, and water is produced here, and the sigma bond convert into pi bond here of the hydrogen. Then here is when sigma bond convert to pi bond, then there is delocalization of pi electrons here. Here is O minus. And here will be the pi bond is formed, and it since it is enolate ion undergoes resonance, and again here is a negative charge, and here is the ketone functional group. Now this is called a carbanion. Carbanion is formed here, and so now the carbanion attack. So this carbanion containing ketone, this is the ketone having carbanion attack So another ketone, another cyclic ketone and the same molecule. Here the negative charge attack the electrophilicity of the carbon. So then there is delocalization of pi electrons here. Then you can write what is the product. Here is ketone. This is attached to another ketone molecule where negative charge. So this is a structure we can get followed by hydrolysis. Then proton will be added to this negative charge. So then we can get what is the product. Here is O, and here is OH, and here is a OH here, then followed by heat. Then here is one hydrogen is lost, or sorry, here is one hydrogen is lost. Hydrogen present here is lost. So now let me write. The proton is taken from here, abstracted from here. This OH is taken in the form of water, H2O. So deprotonation and hydroxyl group and H plus is lost. Then the sigma bond is converted into pi bond here. So then we can get this structure we can get. So this is before heating. So this structure we can get after heating, we can get seq. So is the answer. Now the 16th question, if you observe the 16th question. The 16th question is match the following. So list 1 and 2 here. What match the following is given. Here the list 1 metals are mentioned here. Metals are mentioned. And their extraction methods are given here. Extraction extraction procedures are given. Procedures of their extraction process as given here. So the mercury. So since the mercury has low boiling point and melting point, we can use the method. So distillation process. Refining process we use, and whereas copper is electrolytic refining process we use, and after that silicon is used per zone refining process is used already Valence, and nickel is since nickel vapor phase refining, this also having low melting and boiling, we can use vapor phase refining process we can use. So then what will be the correct option here is that distillation refining second, and electro refining is third, and next electrolytic refining is over, silicon is fourth. So 1 2 3 4 1 2 3 4 1 is the first option, is the right one. And now come to this 17th question. The 17th question, look at the first ionization energy of magnesium is smaller as compared to that of elements X, Y. So the element is given here is that magnesium is given, and it's the first ionization energy of the magnesium is smaller as compared to that of X and Y elements. So definitely X, Y also belong to the same period, and but higher than that of higher than that of what means Y. So Y element. Okay. So magnesium has a smaller ionization enthalpy than XY, and higher for more than that Y. Sorry, Z is given. Sorry, Z is given, and XY. The question is the elements X, Y, Z are respectively. That means here magnesium, the outermost electronic configuration is 3s2, 3s2. So 3s2 means here outermost electrons are paired. So the first ionization energy always more here. I1 value is more. Then if you take a Z, so means more than the Z, so mentioned here, then it might be 3s1, so unpaired. So then first IP value will be less. So here is less, here is a more. So now Z might be 3s1 means it might be the sodium. And XY, so since XY falling in the same third period, then it will be so chlorine and argon elements, we can say, because so after this magnesium, then halogens have higher ionization enthalpy. Then so if you look for these options, argon, chlorine, sodium is matching with this option. 17th one is A. So now the question number 18, if you go question number 18, question number 18. The main products formed during the reaction of 1-methoxynaphthalene with a hydroiodic acid. So hydroiodic acid HI, so decomposes produce HI plus nascent oxygen, where so here is this is OH. Methoxynaphthalene. Methoxynaphthalene means CH3. It is methoxynaphthalene, and treated with HI. So where oxygen is protonated here. So protonation of oxygen. Then so then methyl group, this iodide ion. Then we can get the here is H plus will go to oxygen, will form OH plus CH3I. So here is the major product we can get. So D is the right option we can choose, because iodide, the nucleophile attack the methyl carbocation, but not so naphthalene carbocation. So because it will you the protonation is done here, and methyl iodide is the stable product here. So we can select this option, D option is. One of the reasons steric hydrogens also factor here, the steric hydrogens problem also, steric hydrogens, and the size of the iodide is also bigger. So then naphthalene size also bigger. Better this iodine, prefer this methyl carbocation. Now 19th question, the charges on the colloidal solution CDS, cadmium sulfide and titanium oxide. See, from the colloidal solutions, very important thing. So there are two types of colloidal solutions formed. One is colloidal particles having a negative charge, and colloidal particles having the positive charge. So which type of solutions? Colloidal solutions. Negatively charged, positively charged, right? Positively charged, negatively charged, most of that so sulfide colloidal particles, so negatively charged, we say, negatively charged. Metal oxides, so like FeO and TiO will form that positive charged particles, positively charged particles. That means here negative and positive charge is the right answer. Now 20th question is, an organic compound A on treatment with benzene sulfonyl chloride give compound B soluble in dilute NaOH solution. Compound A is, so compound A is, so then we have to consider so the main reasons. Generally here, second option you can see NH2 is free attached to the carbon aliphatic, and here is NH2 is attached to phenyl and aliphatic. So, and steric tendency is there here, it is insoluble, and here also steric tendency is possible, and here also steric tendency is possible, but in this case the NH2 free is present, and so B is the correct option. It is. Okay, so these are the main solutions for this paper, and so we'll discuss section B, numerical part.